So let me go ahead and just go to my sheet metal and define it as a base flange. Now when we define it as base flange, you can see that's based on our thickness here. It's actually going down inside of our gusset. We always have the ability to reverse our direction, and now we're sitting up on top of our gusset. One of the big questions that people always have for me as far as, when you're dealing with sheet metal is, should we use gauge tables? What's the bend allowance? What's K-factor? Everything like that. So I'm just going to show you really quick. If you click a checkbox to say use gauge table, SolidWorks does have some default gauge tables in there. And if I do a sample table of steel or aluminum, you just simply click on that. And what they'll do is allow different gauges for sheet metal. Now, if you've ever wondered where it actually generates this information from, I'd be more than happy to show you. So all we have to do is go to the install path for your SolidWorks software. So typically that's your C drive, program files, SolidWorks, and then any other SolidWorks folder you'd have, and then Lang English. You find a lot of different things here. This may sound familiar because we actually keep a lot of the toolbox stuff in that same sort of location. But you notice here that we have our sheet metal gauge tables. Then we also have sheet metal bend tables. And that's where SolidWorks by default stores all of this information. So if you've ever wanted to get in there and take a look at how SolidWorks creates these gauge tables or creates this information, all you have to do is go into that folder. If I open up any of these, like our sample table for our steel, notice right here what it does is it says this is based on a K-factor of 0.5. And this will actually change dynamically depending on whether or not you're actually using your K-factor and you're defining a default or a different K-factor. But notice right here that it says, all right, well, with a gauge of 3, this is our thickness, and then this is the available bend radius depending on that gauge. And you'll actually see this come into play in SolidWorks as you pick different gauges. It'll actually give you different bend radius options. So it's all pulling straight from these tables that we have right here. Now notice here's the K-factor samples as well. So if we jump into a K-factor sample, this actually shows us that based on the K-factor and based on the angle of your model, these are the different radii that we could come up with for that K-factor. Now, I am not an expert on these things, so if you guys want to dig into it a little bit further, we also have in our help in SolidWorks, all you have to do is just type in or search for K-factor, and you'll get a menu that looks very similar to this. And it actually gives us a breakdown of what K-factor is. It has the equation for K-factor in there, and also basically the bend allowance. So really all we need that K-factor for is that bend allowance calculation, which should be in your gauge table. So this is just giving you an idea of what it is, what it's for, what you can use it for. Also, what's really nice about our newer help options in SolidWorks is that it has links to things like our customer forum and our knowledge base. So notice right here that down at the bottom it says, well, if this really isn't helping you, you have the ability to gather information based on questions from our knowledge base and based on questions from people that are in the community. So we can gather much information from our help right here. So let me go ahead and jump out of there. And then just getting right back into this, notice again, based on our gauge, we have our option for our K-factor or whatever our K-factor will be. And it automatically picks a thickness and radius information for us based on that. So I'll just hit OK on there. And notice that that does automatically generate a sheet metal piece for me. We can also see up here that it does add that base flange to my cut list. So just like that, we are able to create that sheet metal. One other location that we would probably need some sheet metal is in the sides right here. So we'll go ahead and do that really quick, and that'll just be by picking that face and starting a sketch on it, and then just drawing in our sketch profile. So one of the other things that we can do with our K-factor and with our sheet metal here is just simply draw in a profile that already has bends in it. And I can even make this as shorter as long as I want it to, like that. And then just use sketch relations to lock this into place. So as the size of my sheet metal gets a little bit bigger, as the size of my frame gets bigger or smaller, the sheet metal will automatically update. And let me go ahead and get on my edge filter here so I can pick that up. There we go. on. There we go. All right, so I'll go ahead and make that collinear. And then we'll do the same thing down at the bottom. So I'm going to need to use that sketch profile on this edge right here. Pick that sketch line. And we'll go ahead and make those collinear as well. So once we have that taken care of, we'll just do our smart dimension, define how thick we want that, or how long we want the bend to be. I'll go ahead and make that 10 millimeters. And once that's taken care of, all we have to do is again go back to our sheet metal and define another base flange. Now, once the base flange again has been selected, what we will need to do is define a direction. Again, the up to surface option is going to be really helpful here because we want the sheet metal to constantly update with our thickness. So go ahead and set that. And then right here, we just define what type of sheet metal we're dealing with. So let's go ahead and use that same steel template there. We can define our bend radius. Notice right here we have 6 millimeters, 12 millimeters, 19 millimeters right there. And again, the ability to define what gauge we're using. So if I wanted it to be really small, we could go down to like a 15 gauge. And again, based on that, notice that it changes my radius options. So with that taken care of, I'll just hit OK. And just like that, we have the sheet metal in place. Now again, we could also use the mirror tool here as well. So if I were to go features and do that mirror, we have the ability to mirror those bodies simply by clicking on our plane and defining the body that we want to mirror. And there you have it. Now, one of the last things that we'll do before we start to get into some other things with our sheet metal and our weldments is we need to add these pieces of sheet metal to the prospective sub-weldments. All right, so by taking a sub-weldment that we have right here, we can just simply grab the base flange, that body, and move it up into that folder. So simply by dragging and dropping bodies up into those folders, we're automatically going to generate a new sub-weldment. The one thing I will point out, and this is something that I picked up while I was going through and just figuring out how to do all this or learn all this, you do actually have to take the physical body itself. So by taking like a sheet metal component like this right here, or by right-clicking and updating our weldment profile, how it takes the cut list item right here and turns it into a piece of sheet metal, you still need to expand those and grab the body and move it into the subfolder. So something to keep in mind there. So once you update that profile and these are no longer bodies, you cannot take this cut list item right here and drag it and drop it into the sub-weldment. You actually have to open it up, grab the body, and pull that into the sub-weldment. So from there you can right-click, again, just do an update, and it'll automatically update it as a cut list item in the sub-weldment with the body underneath it. Then you can right-click on there and change the properties for that as well. So notice that by just having that sheet metal classification, we get all these different items in here, like our bounding box area, our cut lengths, and all the information that you would need to properly generate your cut list. So again, just to reiterate, make sure that when you are moving a sheet metal item from outside of a cut list folder into a cut list folder, you actually select the body, not the cut list item itself. All right. Now, one of the other things that's really big and actually new in SOLIDWORKS 2012 is the fact that since we're dealing with a multi-body part, we haven't up to this point been able to create an exploded view for that multi-body part. Well, in 2012, we actually gave everybody the ability to do this now. So this is simply done the same way it was in the other, or in assemblies. You right-click and notice here's the option to say New Exploded View. So when you do your New Exploded View, what we do is we select the bodies that we want to explode or add to an explode, grab the arrow and pull it out in any direction or any movement that we want it to go in. So notice just like that, I can grab that body and move it out. Same thing over here on this side, grab the bodies that we want to move for or explode, pull them out, And just like that, we've added those to the exploded view. So I can hit OK on there, and we've just created an exploded view inside of our part file. So again, it's very similar to what you typically do in an assembly. However, if you haven't ever done it in assembly before, again, it's very simple. You right-click on the configuration, you say Create Explode View, you just pick the bodies, and you define where you want to move them to. If you ever want to get rid of that, you simply right-click on the Explode, hit Collapse, and just like that, we're back to an assembly. Or we're back to a multi-body part, I should say. Now, if you do want to get this out onto a drawing, again, we have the ability to do that by simply hitting the drop-down, making a drawing. It is going to tell us that we need to save it. That's okay. I'll go ahead and just save that.